Okay, let us start the today's session. Till now, the previous classes, we started with the behavioral model. In the behavioral model, what we've seen the conditional statements. The one conditional statement is if statement we studied. In the if statement, we are having three different format of if statements is there. One is if, another one is if else, next one is if else if. That is nested if statement. So you can use any one actually in a program. As we know, the syntax for your behavior model here very clearly. So in this, what is the additional things we said? For every output, whatever you are specifying in the program, that must be declared as a register. Very important, as I said, in the behavior model. Next thing is always. Here the always statement we have to use always at within the bracket sensitivity list. What the sensitivity list will do? It will sense the inputs. The meaning is it will sense means what? If there is any changes in the input signal, then this always statement will execute whatever the statement we written within the begin end. As we know, for each and every always will have the begin end. So, but when we have to use the begin end, if we are having more than one statement here, then we have to use a begin end. If we are having a single statement, so the begin end is not required. It is like equivalent to in a C++ program, like open brace and a close brace. That is what here I shown. Here we seen so many examples. One is like a decoder we studied. Then in three formats, the decoder program we written using scalar inputs and using vector inputs also we written how to write. Then we seen how to represent the numbers in the Verilog. Actually, the Verilog number format, especially see here we shown each and everything how it's supposed to be. The first number specifies how many bit it will be. So I can say simple, it is this 2 will be equivalent to the input you see here 1:0. So this both will be same actually. Then as you know, B that stands for the second one. This stands for the base. In the sense B is binary actually. So here which base you are going to use? The radix, either binary or decimal or hexadecimal or octal. So based on that we have to use here. Then followed by the input, the number. If it is a binary, if you specify it's binary, you should give the binary format. If it is a decimal, you should give a decimal number. If it is hexadecimal, you should give a hexadecimal number. If it is octal, you should give the octal number. So this is the Verilog number formats. So especially when you are going for vector format, you must follow like this only. As you remember, we given some assignments for you like these are the three assignment is given. But now what I will do, let me show how to write for multiplexer. Because earlier we shown if statements very easy. We written the sense for the given input the output will be produced. The same I will say for multiplexer how it has to be written. In simple way I will show now. Module followed by maximum 8 to 1. Then here I am going to use the vector form only. So what and all will be there? First thing is input. Input I will give as I. Next selection line is yes. Then output is Y. Semicolon. Now you go input. Input is I. 8 is to 1. So it is what is the format? 7:0 vector format. Then I. Next input, second input. What is the selection line? How much is selection line? 8 input means 3 selection lines. So it's supposed to be 2:0. Then yes. Then output. Output is single output. So it's supposed to be Y only. Next is register. Register Y. Next is always at what has to come now here. You may have the doubt because two input variables are there. So very clear here what you can do. How many input variables are there? All the input variables will come in the sensitivity list, especially for combination circuits. For combination circuit, whatever the input variables we are using, all the input variable you need to specify in the sensitivity list. Here which are the inputs? I, comma, yes, because both will change anytime. Right? So always at I, comma, yes, I can say, or I or S also may write it. So better we'll go for like this only. Then begin. Now let us start with the if statement. If, what is the first term? If selection line, that is yes equal to 2 dash b 0 0 means the selection line is 0 0, then y equal to what is y? Selection line 0 0 means I is a vector value. You remember, I is a 8-bit value. Now I will say I is a 8-bit value. If selection line is 0 0, what I will get? Simple.
So 3-bit selection line.
Which one? Yes, yeah.
Selection line.
Yes, very small mistake. Fine. 3-bit. Selection line is 3-bit, right? Yes. S equal to 3 colon 0. What will be y now? What it has to select? Y is equal to I of 0. You see this? Now you might have got clear. See, here we declare the vector value. Correct? But the output y is, you remember here, the I is 8-bit. But y is a single bit. Now you see, when I'm writing the statement, this statement, left hand side and the right hand side, the length must be same. Then only it won't give any error. What is the size of the y? Y is a scalar, it is a single. So I of 0 means it's a scalar single. So left hand side is equal to right hand side. That is very clear. See, if I write like this, example I'll say, if I write instead of this, if I write in this way, y is equal to I. If I write, do you think this is correct? This will become as wrong. Why? Because the size of the y is 1, that is 1 bit, but the size of the I is how much? It's totally 8-bit. So left hand side will not match with your right hand side. So this will become as wrong. This is wrong. This is wrong. You should not write. That is the reason. So now first statement is over. Next. Yes. Again, what I will do now? Else if will go. Because the first condition is not at all satisfied means next what I will do? Yes equal to 3 dash b 0 0 1. Selection line is 1. Then what is y? Y is equal to I of 1. You may think I'm writing in single line. That is also fine. Even you can write like this. This is also correct. That's also correct. You can write like this also. Because anything is fine. So don't worry about that. Why you written in this way. Now next, again, else if. Control C, I will do this. Yes, else if S is equal to 1 0. That is 2. If S equal to, then output will be what? Select I of 2. Next is equal to what? 0 0 0 1 0 1 0 0 1 1. It will select I of 3. Just like I'm just replicating your truth table only. I'm not writing anything new here. You see this. Next, what is this here? Your selection line is 4. S equal to 4. 1 0 0. So I of 4 will be selected. Next, here 5. 1 0 1. Then I of 5 will be selected. Next, 1 1 0. Next is 1 1 0. 1 1 0. Then I of 6 will be selected. What about next? We won't get else if. So the final statement is what? Else only. Else. Then this condition will not come. Straight away we'll write this. Y is equal to I of 7. Because all the combinations we checked. Only the combination what? If it is not satisfied, the final combination is what? 1 1 1. So y equal to I of 7. Then we'll close with end. Then we'll write with end module. Yes. So this is the program for 8:1 multiplexer. But when you're going to check, how we'll check? You may have doubt, right? Now what I will do, my input, that is the input I is equal to, that is I'm going to give the I value. Let me give I value. Yes. See, I is equal to, I will give the value input as like this: 1 0 1 1 0 1 0 1. See, 8 bit is there. Correct. Now, what I will do, this is my input I given. Now, I'm going to give, yes, selection line. Selection line is equal to yes 0 0. Then what will be my output? See, output y. Now, see I. What is the size here? 7:0 means this is 7. Correct. This is I of 7. This is I of 0. Correct? No. I of 6. I of 5. I of 4. I of 3. I of 2. I of 1. See, these are the corresponding index positions. So this will be I of 7, is I of 6, I of 5, I of 4, I of 3, I of 2, I of 1, I of 0. Now, when I give selection is equal to 0, 0, 0, it will enter into this program. You will see where selection is 0, 0, 0. Then y is what? I of 0. We given the input vector form, but the y will be selected as what? Will be not this, sorry. Yes, it will be selected what? 0, 0 means it will be selected this. Then y will be 1. Next, I'll give s is equal to 1 0 1. Now what will be my output? 1 0 1 means, see from this program 1 0 1. It will see 1 0 1 y equal to I of 5. Where is I of 5? See, I of 5 is here. This is I of 5. So output is 1. Like this only the multiplexer will produce the output. The application of multiplexer already we know. I hope you remember your television. Single cable, multiple channels will come, but with the help of the remote only you can view only one channel. I hope this is clear. Is there any doubt in this? The multiplexer? Case statement. The syntax for the case statement is case. The case is a keyword followed by condition or expression, then come by input signal colon, here the begin, some statements will come, end, input signal 2 begin, some statements end, input signal begin, some statements end, finally the last is default semicolon, then begin statement end. Now you can see here these are all your corresponding the condition values will come. The right hand side here, the begin end, use as you know, the begin end when you use, if you are having more than one statement here, then only begin end will come, else there is no begin end. So finally you have to close with the end case. You can check that there is no space between end and case. It's a single word. End case is a single word. So you might have seen in your C++ or C programming, like switch or break statements you might have used. Same like this only. So now what we are going to do, they took the example as 2 to 4 decoder using the case statement. So this is already we written for using if statement. This is common. There is no change in this. Even this also is common. Not. Only thing is the new thing is where you written. This is our new now compared to the if statement, right? Now here case followed by within the bracket what? Condition or expression. Which is going to be control. That is what here actually. The D1 is going to be control actually. Because when D is having some value, based on that, it will produce the output. So D, then here the input signal, see, you have to specify like this only. 2-B00 because the size of the D is how much? 2 bit. So 2-B00, that is when D is 00, then you know the truth table. There, Y will be what? Y of 0 will be high. See, rest of the values are this. You may think, why can't we written as like this? 2-B00. Instead of this, you can write like this also. Y of 1 or y of 0. Y of 0 is equal to 1. Even you can write like this also. Both are correct. You see this? Because our aim is what? When the D is 0, 0, Y of 0 will be high. See this? What is the difference given? See, left hand side and right hand side both should match. See here, the left hand side is Y variable. The Y variable is how many bit? It is a 4 bit. So right hand side, you see what are we initialize value, what is the value given, 4-bit value given. So it will match. Now you see here, y of 0 is a scalar now. It is a scalar. It's a 1 bit. Now you see right hand side also 1 bit. So both will get matched. Either this or this also you can write. So same the way 0, 1 means y1 will be high. 1, 0 means that is 2. Y of 2 is high. By default, if these three combinations are not work out, then final combination will be what? The y of 3 will be high, and the case n modules. This is what the decoded 2 to 4 using case statement.